spacing. I took it all off. Sorry, I should have done 10.
Take another pass.
Well, let me see. Oh, no, I didn't. Okay, good.
Okay. Alright, now pay attention. He took a pass, crossed there 20 thousandths, it did not clean up.
Notice I still have saw marks here, so you want to...
The idea is you want to get it so it's nice and smooth, those saw marks.
See over here, it's not quite clean yet.
You want a good surface finish. You're going to see this end. Alright? The other end, it's not going to see because it's going to be covered by the cap. But that needs to be equally well machined because it's going to fit up with the cap piece. So, you need to make sure that everything is machined well.
Alright, so I'm going to make another pass because it's not cleaned up yet. They came in another 20 thousandths.
Notice this style, hand for hand, nice and smooth.
And then don't race back to the start. You come back the way you came. You'll get a little tiny bit more off. We call that the spring cut. Alright, it should be clean now. Let's take a look.
You call that the what coming back?
The spring cut. If you think of it as you're relieving tension in your piece, no machine is perfectly rigid no matter how big. So it's got springiness to it, or it'll spring a little bit, so they call it the spring cut. I'm guessing that's why. I'm just guessing. Alright, now it's nice and clean. The reason we want to clean is twofold, so that our cut is perpendicular to the axis of the piece, and when we get both ends clean, we have something to measure. If we have two saw cuts like this, there's no point measuring anything. So that's one side. So now I'm going to flip it over. Oh, chamfer tool. Yes, this is also very sharp right now.
Yeah, so you're going to go in there and we're going to put 15,000 chamfers on both the inside diameter and the outside. That is going to be on step 3. Now, when you do this, you want to keep the part in the chuck until you get this operation fully done. The idea is not to face it, take it out, look at it, put it back in, chamfer it. You want to face it off, chamfer it, and then you're done. Keep the part in the machine until you've done every operation you fully can without, until you have to take it out, move it, measure it, and some other operation. The more times you keep it together, with it less in and out, the more accurate it will be.
This time, okay, this time it's a chamfer tool, so instead of using the point, I'm going to use the edge. Same idea though, I'm going to just touch. I'm going to set this at 0. And I believe your plans call for 15 thousandths chamfer, so I'm just going to keep going that way, 15 thousandths. Just like that. Now I got rid of that sharp edge. I'm going to clear my tool, come to the inside, do the same thing again. Use the edge, not the point. Until it just touches. Set my 0, come in 15 thousandths. There, 2 15 thousandths chamfers. And then I'm going to look at it. That may or may not. It actually didn't get rid of all the chamfer on the inside.
Okay.
So that means I could have touched it a little bit better when I started.
Alright. Essentially, if you find this condition where it has not fully got both on the inside and outside, go and do a 10,000 to make sure that you get chamfer all the way around. Due to the eccentricities of it, it may or may not be done. But you definitely want at least a minimum of 50,000 chamfer at all at one point to get the deeper. But at least 50,000 it's not putting together and out there.
My outside one looks fine. I can see the bevel, the chamfer all the way around. I went another 10 on the inside. Since I had just done the inside, this was still set at 0, I just proceeded another 10. So now this end is clean and chamfered. And there's nothing else I can do at this end, or do you want me to do the boring?
No, we're going to turn it around.
So I'm done with this chucking. There's nothing more I can do with it like this, so I'm going to turn it around.
Not right now.